Miss Morel, I was so excited to see you in class today, but unfortunately we have a flexible learning day. That's just the way life goes. Alright, so today we are going to do 6-1 angles of a polygon. So you should be taking notes in your interactive notebook, so you should have that out. Okay, 6-1 angles of a polygon. And we're just going to break this into part 1. So today we're going to be focused only on the interior angles of a polygon. Okay, so remember, interior angles means the inside angles. Okay. So we're going to study a theorem that is the Polygon Interior Angles Sum Theorem. And remember, sum means to add. So what this theorem is going to tell us is when we add all the inside angles of a polygon, it equals, and then we're going to do a little bit of some showing here. So it equals, okay, we're going to start with a triangle. Okay, so a triangle is 3 sides you can draw your triangle however you'd like. But we know when we add all of those angles in a triangle, 1, 2, that's a pink, and 3, we studied this before. When we add all 3 angles, triangles always add up to equal 180 degrees. Okay. Now if we do a quadrilateral, a quadrilateral is 4 sides. So it could be a rectangle, it could be a square, a parallelogram, a kite, a rhombus. There's lots of words that we can use. But pretty much we just need to have at least 4 sides. 1, 2, 3, 4. It doesn't have to be perfect in any sort of way as long as there's 4 sides. Now we're going to go off the basis that we know that a triangle is 180 degrees. So if I can break this quadrilateral up into triangles, then I can know that each of those triangles would make 180. So we're going to use diagonals, and diagonals connect from one vertex to another vertex. So it has to go from a corner to a corner. Okay, so if I connect this corner here, if I connect it to that one, that wouldn't work. So I'd have to go across. And in this quadrilateral here, I see that it would make 1 triangle there and another triangle down below. So in that quadrilateral, in this top part, we have 180 degrees, and down here we have 180 degrees. So total, that would equal 180 plus 180 would be 360. So I know a quadrilateral is going to add up to 360 degrees because it's really 2 triangles on the inside. Alright, then if I have a pentagon, a pentagon has 5 sides. So sometimes can look like a house. 1, 2, 3, 4, 5. So 5 sides. 1, 2, 3, 4, 5. I'm going to ask myself, how many triangles can I break that up into? So if I do this first triangle here, that's an easy triangle for me to see. That's 180. And then I'm left over with a quadrilateral, which we already did. So down here below, I can break this into a triangle here. That's pink. I know it's hard to tell the difference between my pink and my red. And then there's one more right here. So in a pentagon, we'd have 3 triangles. And each of those triangles would be 180. So 180, 180, and 180. So really we took this quadrilateral and we just put another 180 on top of it. So we're just adding another 180 to 360, and that would give us 540 degrees. All right, let's do this one more time. We're going to now do it with a hexagon. And a hexagon has 6 sides. So 1, 2, 3, 4, 5, 6. This is different than that. Okay, so 6 sides, doesn't matter how it looks. And we're going to break it up into those triangles. So I'm going to start with where I see a triangle the quickest, which is this one here. So here's one triangle. So that's 180. And now I feel like I'm back down to 1, 2, 3, 4, 5 sides. So out of the 5, I should be able to make 3 triangles. So 1 triangle. And there's another one. 2. And 3. So this time I was able to make 4 triangles with 6 sides. 180, 180, 180, 180. And so we had 540, so we're just adding on 1 more triangle, so we get 720 degrees. So anytime we have an n-gon would tell us it has n amount of sides. What we're going to do is we're going to realize how many triangles there are in each one. And in each one of these, when we have a triangle, there's 1 triangle. So 3 sides means there's 1. 4 sides means there's 2. 5 sides means there's 3. 6 sides means there's 4. So because we started a triangle, we're skipping the first side and the second side, and we're just saying 3 sides means 1. We're going to do n minus 2, because that's going to tell us that when we have 3 minus 2 would tell us that there's really 1 triangle. Okay, here if I have 6 sides, 6 minus 2 would be 4 triangles. 1, 2, 3, 4. And then each of those triangles we would multiply by 180 degrees. Okay, so that's my really big theorem today is the n minus 2 times 180. So we're going to do a couple examples with that. We have 3 examples to do. I'm going to flip this over to the back page. I'm going to just write, since I switched this over to the back page, I'm just going to write that theorem down. If I have an n-gon with n sides, that tells me I'm going to do n minus 2 times 180. But that's the sum. Okay, so this is the sum of interior angles. Okay, so for example 1, we're going to do this, find the sum of the angles in an octagon? Okay, so an octagon is 8 sides. So we're going to use our formula here, n minus 2 times 180. And I'm going to plug in 8 for this n. So I'm going to do 8 minus 2 times 180. And 8 minus 2 is 6. So 6 times 180. And I don't know what that is off the top of my head, so I'm going to use my calculator. 6 times 180 is 1080. So the sum of angles in an octagon is 1080 degrees. Alright, number 2. We're going to find the measure of each angle in a regular 14gon. Okay, so now in this case, it's not asking us for the sum like the last one was. In the sum, we just use that formula, we just plug it in, and then we are good to go. Okay, so in this case, we have to find the measure of each of the angles in the 14gon. But before we start by finding each of the angles, we're going to find that sum. So in a 14gon, that means that there are 14 sides. And that also means that there are 14 angles. And because it's a regular means that they are all the same. They are all equal to each other. Okay, so let's think about this as a 14 minus 2. We're going to do our n minus 2 times 180. 14 minus 2 would give us 12. And again, I'm not quite sure what 12 times 180 is, so I'm just going to use my phone calculator. 12 times 180. I know the lights on my ceiling are kind of crazy. 2,160. So that's how much they are all together. But I need to split that apart into each angle, because I want each angle. So to split apart means we are going to divide. And we know that each of them are equal, so we can divide evenly. We're going to divide it by our 14 angles. So we're going to do 2,160 divided by 14. And we get about 4.29, because that 5 tells us to round up. Oh, not 4. Whoops. I was like, there's no way. Sorry. 154. I didn't even look. 154.29. Alright. So that's going to be our final answer, is about 154.29 degrees. Because if each of them is equal to that, and we add that up 14 times, we get 2,160, which would be our total sum. Alright, last one, number 3. Okay, number 3, we're going to try a drawing here. It's going to be a little goofy. Okay, we're going to do a pentagon, so 5 sides to the best of your ability. We're going to have this be X. This is, nope, this is 2X, I'm sorry. 2X. This is 4X. This is 3X. This is 5X. And this is also 5X. Okay, and we want to find x. Okay, so as you notice, these are the inside angles, so we're going to use our interior sum polygon angle theorem, polygon interior angle sum theorem, which tells us we can do n minus 2 times 180, and n is the number of sides, so here we have 1, 2, 3, 4, 5. However, we did this one already. If I flip this over, we can find when we did a pentagon, when we did 5 sides, it was 540. So we could go through all that work, but we know it's just going to be 540. So 5 minus 2 times 180, it's going to equal 540. So now I know that all of these together are going to make 540, so I'm going to write that out as an equation. I'm going to have 5x plus 2x plus 5x plus 3x plus 4x equals 540 degrees. And we can solve this equation. And by doing that, we're going to find out how many x's are there all together over here. So I have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 19 x's. If we just combine all of our like terms. So we know 19 times what number is 540. We could write that as an equation and divide both sides by 19. I don't know what that is off the top of my head. So here's my calculator. 540 divided by 19. Did I add that right? I did. Okay. We're going to pretend that that turned out the way I wanted it to. This was exactly what I was expecting, guys. 28.4. It wasn't, but that's okay. Okay, so each x is 28.4, and we aren't going to say degrees because they aren't the total angle. But our directions here were just to find